Hello everyone, welcome to our pre-calculus lesson 22. In this lesson, we will discuss how to transform the quadratic functions, which means that there are a couple of ways without drawing all the quadratic functions, we can actually move them from one place to another, keeping the same shape. And how to do that? That technique is the main agenda for today's class. So these are the agenda. First of all, we will review the basics of quadratic functions. Then these are the things that I was talking about, transformation for the quadratic functions. So we will flip them, that means upside down or downside up. We will do that. Then stress or compress, so there are like graph can be wider, graph can be narrower, that thing we will do. Then vertical shift, that means graph goes up and down, this is vertical shift, we will discuss that. Horizontal shift, that means left and right side graph will shift, we will discuss that. Then we have two more things from the vertex form of the quadratic functions. We will discuss these two topics. One is vertex form to graph and graph to vertex form. So these are our plan, and then practice, of course. So let's start. From basics of quadratic functions means already we have discussed it in our last class. Just some review. Ax squared plus bx plus c fx equals to this. This is the quadratic function where the main condition is the value of a cannot be 0. The value of a cannot be 0. This is the graph of quadratic function. You can see this is up opening parabola. If the value of a is positive, then the graph will be like that. If the value of a is negative, then what? If the value of a is negative, then the graph will be like this. If a is negative, suppose the value of a is negative, then the graph will be like that. And if a is positive, then the graph will be like this. What does it mean? Suppose if the question is like 2x squared or x squared only, then plus something, then the graph will be like this. And if the graph is minus 2x squared, negative some value, then something after this, then the graph will be down opening parabola. And actually this topic we will discuss in the next pages also. What happens if we give minus, what happens if we give plus, and we will discuss it. So the name of this graph is parabola. This is up opening parabola. The upside is open, that's why up open. And this graph is down opening parabola because downside is open, that's why. And this point is called the vertex because this is the minimum point of the up opening, and for this graph this will be the vertex. This is the line of symmetry. And why we use this quadratic function? To find out the area of an object, acceleration, including the gravity, revenue. We will discuss a couple of these maths in our application class, which is actually next class. In the next class, we will discuss the couple of applications from here. Now, let's start this. The thing that we said that the movement that we will try to move our function or the graph, and how we will do it. Let's see. So this is the vertex. We have this x squared graph, and when x equals to minus 2, minus 1, what can happen? So we can actually change this graph in a lot of ways. Suppose this is fx equals to this thing. Fx equals to x squared. So this fx equals to x squared it can be minus x squared sometimes, or we can say that okay, x squared then plus 2. We can change it like this, or we can say that x plus 2 whole square. Like this also you can write. Or we can give some minus here, suppose minus 3. Or we can give here some number also, like some number 1, 2, 3, suppose 2. So there are many ways actually we can give additional things with this x squared. And for all these things, there will be some impact on the graph. For everything that we do, there will be some impact on the graph. So these are the things that we can do if with this f x equal to x square graph. If x equal to x square, this is the graph. So we can give minus here before the x square. We can give some number before the x square. We can give some number like x square plus. We can add some constant number, or we can some number within the square, within the square some constant number. And for everything there will be some change. What is that change? Let's discuss. Yeah, last one is like mixed. We can mix them up also. So first change is what happens if we give a negative. Yeah. So actually, if you give a negative before the function, then the graph will have the upside down thing. If the graph is already upside, then it will go downside like this. So that everything will remain same, just the graph will shift, like flip about the x-axis. Everything will remain same. Okay, vertex is the same point. Vertex is not changing, and the graph will be like, if the graph is upward, then the graph will come down. Suppose if the graph is here, then this graph will just as you can see, graph will go down. And if the graph is already downside and you give another minus, then the graph will go up. So for this extra minus before the function, we will have some flip about the x-axis, upside down or downside up. The same graph it will just do that for this extra minus, for this minus. Now what happens if we give some, let's say before the x squared, if we give 2, 4, 3, what happens if we give some additional number? Actually, if you give some bigger number than 1, so there can be this number. Suppose we have the graph x squared. So what type of number, instead of giving minus, what type of number we can give here? We can give here already we have what here? What number we have here before this x? Already we have 1. So we can give two type of number here. Some number which is more than 1, like 2, like 3. This kind of number we can give, or we can give 0.1, like 0.2, decimal number. So or we can give 1.1 also. If we give 1.1, then it is more than 1. So it will go above 1. So what can we give is some number above 1 or some number below 1. So what will happen for that? Roughly, if you give some number more than 1, then for that the graph will actually have some compression. The graph will be like narrower, and the graph will be narrower like that for this number above it. And for the number below this, like for this kind of numbers, the graph will be wider. Say, of course, the shape will remain same. Shape will remain same. The graph will be narrower. For different numbers, of course, the narrowing rate will be different. So the narrowing rate will be different. So what happens if the number is more than 1? Then the graph will become stretched, compress, or narrow, whatever you say. The graph will be narrow, compress or narrow. The graph, suppose the graph was like this. If the number is bigger, then the graph will be like this, more narrow. It will start moving up more. Suppose the graph was like this, and then if you give less number, then the graph will be more stretched, or more wider, you can say. So let's look at this. And let me clean it up so that you can see. So you can see it. If it is 2x square, the graph becomes like more narrow. If it is 4x square, then the graph will be more narrow. See, you can see that. And why it happens? If you ask, sir, why it happens? The reason is, you see, basically, suppose x value is 1, then what you are doing? You are multiplying that 1 by 4. Suppose x value is 2 here, then 2 square means 4. 4 into 4 means 16. So without this 4, the function is only 4 here, if you put 2. But when you give here extra 4, then function becomes 16. That means number becomes really big, which means the function rises too fast. If you give some more number here, function rises too fast. If you give less than 1, 1 by 4, 1 by 4 means 0.25, decimal number. Then, as I said, the function will be wider, like that. Function will be wider. Okay, and vertex remains the same. Vertex do not change. So what I said is written here. If the number is more than 1 and if the number is less than 1, what will happen? So flipping and both things, this is practice. You can think about it, what will happen. So you can see, if you want me to show the first one or a couple of, then this is x square minus 2x square. So suppose normally our x square graph is this. Okay, for minus x square, for minus, it will be what? It will be flip, downside. So the graph will be like this. But there is another additional 2. So for this extra number, graph will be little bit narrow. For this extra number, graph will be little bit narrow. Little bit narrow. So this is the final answer for f(x) equals to minus 2x squared. So you see, this is our main graph, which is x squared graph. Let me write it step by step. And this rate is minus x squared. And this is minus 2x squared. Of course, you can say, sir, where is the value? This is the rough estimate, but it will match with the answer here. Let me show you the answer. So you see, this is the answer for our different colors. You can see this minus 2x square. This is the graph minus 2x square. You can see the color combination also. 3x square graph is here. F(x) equals to 1 by 2x square graph is here. There is a minus. That's why it's down. Then 1 by 3x square graph will be where? Roughly 1 by 3x square graph will be here. Suppose, already it's here. See? Then 0.2 x square graph will be here. 0.2 x square graph will be here. So you see, because of the decimal, the graph becomes wide. Because of the extra number, suppose 3, this is a big number. If the number is more than 3, then the graph will be narrow. If the number is less than 1, more than 0, of course, that means some decimal value. Now you can say, sir, 1.5 also decimal, which is more than 1 decimal. Okay, more than 1. We are talking about like from 0 to 1. Within this gap, if the number is within this gap, then the value will be, the graph will be wider. So this is what happens for the two things. Let me clean it up and discuss another topic. Vertical. Now this is vertical shift. It means that graph. Now the graph will actually move up or downside. See why it happens? Because you see, this is x squared plus 2. X squared graph. This is x squared graph plus 2. Plus 2 means Now this graph will go to the positive 2. The same exact graph will go to the positive 2. See, the graph will come here. If it is minus 2, then the graph will come down here, like that. So x square minus 3, so the graph will come here. See, the graph is here. Vertex, of course, vertex also changed. Vertex was here, now vertex is here. And now vertex is here. So vertex actually changes as the y coordinate changes. That's all. So this is the rule. If the value of k is positive, then it goes up. If the value of k is negative, then it goes down. So the previous this slide is for up and down shift, which is called vertical shift, up and down. Now this one is horizontal. It will be like left right, and there is some clear difference why it happens. See this. Where is this 2? This is within bracket x plus 2 whole squared. That means this is now within bracket. If it is within bracket, then first thing you should think, okay, this is now horizontal shift, left right shift. Okay, and if it is plus 2, then interestingly it will go to the negative 2 point, this here, negative side. See, the point graph comes here. If it is a negative 3, this is a rule. Why it happens, we will explain it here. If it is negative 3, then the graph will go to the positive 3. This is little bit variation or difference from our horizontal shift, vertical shift. In the vertical shift, we said that if it is plus 2, graph goes to plus 2. If it is plus 3, graph goes to plus 3. If it is minus 3, graph goes to minus 3. But here it is opposite. If it is minus 3, graph will go to the plus 3. Graph will go to the plus 3. Why it happens? Because of this. Because we need to cancel out the number. We need to put some number for which our this value becomes 0. This is x minus 3. So for at x equal to what, our this value becomes 0. X minus 3. So for x equals to what, this value becomes 0. This value becomes 0 at x equals to plus 3. At x equals to plus 3, that's why this value becomes 0. And at that point, this value becomes 0. And plus 3 is where. And now you can ask me, sir, why we have to make this value 0? What's wrong? The reason is, you can see that when it goes to the horizontal shift, left and right, basically our y value is what? On this point, our y value is what? Y value is what? Y value is what? Y value is 0. Here y value 0, here y value 0, here also y value 0. That means our fx means what? Fx means y. That means we have to check where is our y value 0. Okay, y value needs to be 0. Because of our vertex. Our vertex is still on the x-axis. At x-axis, everywhere y value is 0. That's why. So this is the horizontal shift. Yeah, we are saying the same thing. Where it is 0, we have to check it. Suppose x plus 2 whole square is written, then we have to write, okay, x plus 2 square equal to 0. X equals to what? X equals to minus 2. So the graph will go to the minus 2. Or simply just you can think, if it is x plus 2 within the bracket, then the graph will go to the minus 2. If it is minus 3, then the graph will go to the plus 3. The reason is this. Now this is a this is a combined thing. See, the graph is moving. So let me show you step by step. First of all, what will happen? What will happen? Let me see. Let me tell you that. Or let's discuss together. For this x plus 1, this is within bracket, right? So for this plus 1, what will happen? Within bracket, left, right. bracket means left right. And if it is plus 1, we know that rule is then the graph will go to the minus 1. And so for this plus 1, for this plus 1, graph will go to, for plus 1, for plus 1, graph will go to minus 1. Graph, by graph I mean vertex of the graph, okay? Vertex of the graph, minus 1. And for this plus 3, what will happen? This is extra number outside. The graph will go up or down? Up. For the plus number, graph will go up. It looks like I have a student here. It looks like I'm asking them. For this plus 3, graph will go up 3 units. So graph will go 3 unit up. And for this 0.5, graph will be narrow or wide? Graph will be narrow or wide? Graph will be, I'm just breaking down all the things, okay? For this 0.5, graph will be wide. The graph will be wide. The graph will be wide. Suppose this is our something. I have my headphone. I can try this. Suppose this is our graph. For the 0.5, the graph will be narrow. Suppose, okay, let me show. Suppose this is the graph. For the 0.5, graph will be like this. More narrow. It will become more narrow. Like that. So for the graph will be, for the 0.5, it will be wide. Now there is a minus before 0.5. For this minus, for negative, for minus, this minus is very sensitive, very important. For minus, graph will flip. That means upside down. It will come upside down. So let's see if it is happening. If it is happening. So see, first of all, graph goes to minus 1. And then graph goes to plus 3. Then flip. Then 0.5 wide. For 0.5 it will. Now you can say, sir, is it necessary that I have to do this first, this second, this third? Is it necessary? No, that's not necessary. You can actually do it in order. But this is best to actually do this stretching thing finally at last. Then your work becomes little bit less. But it's okay. You can do in any order as long as it works. Everything is good. So let's recap. For this plus 1, the graph will go to the left side. For this 3, graph will go to the upside. For this minus, graph will flip. For this 0.5, graph will be wide. Okay. So this is how we can draw the graph. This is how we can actually draw the graph from this form. This is called vertex form because actually from this point we can actually exactly get the vertex. This is our vertex. What is the coordinate of the vertex? Coordinate of the vertex is minus 1, 3. Minus 1, 3 is the coordinate of the vertex. And from this point, you can see this minus 1 came from where? Do you know? This minus 1 came from here, this place. This is plus 1. So vertex will be at minus 1. Why? Because our formula, there is an extra minus in the formula. So if the number is plus, for this minus, actually it will be minus. If the number is given, suppose in the question, suppose if I give you x plus 2, suppose if I give you x plus 2 whole square, x plus 2 whole square minus 5, suppose, something like this. That means your vertex x value will be then at minus 2, and then this is plus 3. This value will remain same. This is the vertex y value, and my vertex y value is minus 5. So for this question, vertex will be at minus 2 and minus 5. This value is as it is. Y value is as it is. Y value will remain same. But because see, this value is plus k, no problem. But h is negative. H is negative. So if it is positive given, then we have to give it negative in our actual math. or even without thinking also you can actually just follow the transformation and automatically you should get this point from the graph. You will say okay, -1 then -3. So this is the vertex, and this is the vertex. So this form is called the vertex form because from this form we can easily find out h and k or the vertex. H comma k is called the vertex. H comma k is called the vertex. Okay. Now suppose x square plus 1, x plus 1 whole square. This is kind of practice. You can just roughly draw the graph, and then we will show the answer here. I will show the answer here so that you can try to match it. Just roughly you can draw the graph. You can roughly try to draw the graph. Just a rough graph. Just try to draw of all of them. Then we will try to match. So this is x square plus 1. That means, suppose if you tell me, sir, okay, now you draw a rough graph and show us that your answer is correct. Okay, so our x square graph is something like this. So our first answer, plus 1, this will go to the plus 1 side. Same graph will go to the positive 1. It will go there. This will be the first answer. Okay, let's check if it is correct. See, this is correct. Roughly, roughly this is correct. Of course, I am not drawing the same shape. Then I will try to draw if x equals to x plus 4 whole square minus 2. Where it will go? Oh my god, now I do not know where it will go. So for the minus 4, this is x plus 4. I will not draw all of them. If you want, I can actually. But let's draw the last one. Let's draw the last one. So there is two things will happen. One is for minus 2, this graph will go to the down to 2 unit, and for the plus 4, the graph will go to the minus 4. So minus 4 is here, and then for the minus 2, graph will come here, and there is no minus. That means the graph shape will remain same. The shape of the graph will remain same. That means the graph will be something like this. Last one, last one. So let me show you the answer. See, last one graph is red color graph is here. Other thing also. Now, like quickly, if I ask you, okay, suppose if I block this, if I say that, okay, find out this graph is which one here. Suppose if I give you a lot of graph and ask you which one is here, how can you find out? See this coordinate, this vertex is what? This vertex is minus 3, 3, and where is this minus 3 and 3? Here. This is plus 3 and minus 3 actually, plus 3 and minus 3. So this one. So basically, from the graph, we also understand which one is the question also. Which one is the question also. And then vertex form to graph also we can practice it. Already answers are given here, but we can try also. Same process for this plus 1, what happens for this 1, what happens for this 2, what happens for this 2. The graph will be a little bit more narrower, which is you can see shape is a little bit narrow, etc. Then graph to vertex form. This is new thing, so I will discuss one math from here. This is also actually from the previous concept. It goes. Let me check another thing. Okay. So from this, so how can we now, suppose now the graph is given. Now what? Graph is given, question is not given. Question is not given. So how can you find out the question? This is little bit, it will take some time. It will take some time. So let's start. Fx equals to this. Fx means y, right? You know that. Fx equals to y. Now you can choose some graph, which one we should do. Looks like this graph is a little bit wider, so let's try to solve this one. For solving all the math, the process is same. Actually, this graph first one is too easy, so let's try to solve this one. What is this value? This value is 2 comma minus 2, right? 2 comma minus 2. So this is the vertex, and there is some y-intercept here for this graph. Y-intercept is 0 comma minus 3. 0 comma minus 3. So what we will do is, first let's put the h and k value. So y equals to a into x minus 2 whole squared, then k value is minus 2, so k value is minus 2. So x minus 2 whole square, then minus 2. Of course, there will be a negative before, because it is down opening parabola, so there will be a negative. So let's give a negative because it is down opening parabola. Now you see we have almost everything we have, but the value of a we do not know. How can we find out the value of a? Let's check it. We can put this value in the function and try to find out the value of a. So in this case, this value is 0 comma minus 3. That means x equal to what? X equals to 0, y equals to minus 3. This value. Since we are working with the graph of this function, so this equation must be satisfied by this point. Actually, if you think about any points on the graph, anywhere, all the points will be satisfied for the correct equation of the graph. Okay, by satisfied means you can put x value and y value in the both side, then the left side and right side will be same. So this is a very basic fundamental rule of algebra. You can actually check any equation with this graph. From the graph, if you put the point in the equation, you will see that they will match if they are correct equation of the graph. If this is not correct equation of the graph, then they will not match. By match, I mean left hand side and right hand side, they will be same. Or if you bring everything in the left side or right side, then answer will become 0. Satisfy means that if you put for any equation, suppose equation is given and graph is given. From the graph, if you put value in the equation, final answer will become 0 if you bring everything in one side. This is what I mean by satisfying the equation. Okay, now let's put this value. So x equals to y equal to minus 3 equals to minus a. Actually, without this minus a also we could solve this math. This value is 0. If you give that minus, if you don't give that minus a, then additional minus will come. But that's not our target now. So what happens here? Let's look. If I send this minus 2 to this side, then it will become plus 2, then plus 2 and 1, it becomes minus 1. That means ultimately I have minus 1 equals to minus a into, what is this? Minus 2 whole square. Minus 2 whole square means 4. So then from both sides, 1 cancel out. That means a equal to 1 by 4. A equals to 1 by 4. So what is my final answer? My final answer for this graph is fx equals to first of all minus, because the graph is downside, as you can see. Then the value of a means already we have found 1 by 4, so equal to 1 by 4. Then x minus 2 whole square. The remaining thing actually you can directly write x minus 2 whole square, then minus 2. This is the answer for this graph. And for this one, for this one, for this one, for any of the graph, the process is same. Let me remove it and let me show you all the answers of the questions here. So for the first one, this is the answer. Second one, this is the answer. Third one, this is the answer. And last one, this is the answer. The math that we solved here. See, same answer. Same answer. Now, so now you have this practice math homework practice. I will not solve it. I will not solve it here because we already solved. Your task is to find out. Your task is to find out which function and graph is matching here. A number, which one, B number, which one, C number, which one is matching here. Your task is to find it out. Okay. Yeah, and you can do more practice 11, 12, and 48, 52 number from this pages from this page number. This first two math is like this, like this. First two math is 11, 12, 13, 14 also. They are somewhat like this. After 11, 12, actually the equation is given in different form. So 11, 12 you can try to practice, and then 48, 45. 48, 45 number is something like this math. Something like this math. Something like this math. So you can give a try, give a practice, and in our next class actually we will start doing the application of this all these things that we learned from the quadratic functions, our basic and the analysis of the functions, calculations, algebra, all these things are almost done. Of course there are a couple of things that will come in our coming next class also, but next class mostly we will start doing the application of the quadratic functions. All right, thank you all, thank you very much. Have a good day everyone. Bye bye, see you in the class. Bye.